Okay, so for this week's homework, I wanted to go over some output. If you remember from t-tests, I brought up some Facebook data. So I had looked at my number of mutual friends based on if that person was a family member of mine or if that person was a friend of mine. And so I had one IV and it had two groups, and that worked really well for the t-test. I have now enhanced that data and added a state. So this is made up data. I went ahead and looked at, do they live in the same state as me, regardless if they're friend or family? And so now I'm wanting to run a 2x2 factorial ANOVA. This is a between subjects design because you either are a family member or a friend for the family factor. You either live in the state of Arizona or you don't for the state factor. And then with the factorial ANOVA, we have the awesome possibility of having an interaction. Are there differences based on if you're a family member and live in the state, or if you're a friend and you live out of state, or you're a friend and you live in the state? So the top portion of our data shows our factorial ANOVA. So since I'm running a completely between subjects design, I do need to check for the Levine's test. So the Levine's test is one of the variances assumptions for equality of variance. Equality of variance you can also call homogeneity of variance, and I meet that assumption. Again, that's just for a between subjects design. I'm just going to remind you of that. And you want P greater than 0.05. P greater than 0.05 means my groups are not too different in terms of their standard deviation or variance. Okay, and so then I want to go ahead and take a look at my results. So I am getting a report of eta squared. So remember, eta squared is your effect size. So I'm going to note that for us. And we also are given our three Fs. So our three Fs are an F for main effect, so I'm going to start color coding for you. So an F for a main effect of family. I see that there's no effect of family. And then I have an F for if you live in the state of Arizona or not. Factor 2. Factor 2 is highly significant. Again, anytime you have a P less than 0.05, that means you have significant differences. And then, of course, it's always fun to look for that interaction. And I do not have an interaction. Remember that I said you usually have an F of 1, and that indicates that any variance going on between groups is swallowed up by variance within groups. We have kind of an awful situation with this made-up data with our interaction where our F is less than 1, which means we've got a whole lot of individual groups, individual differences going on within those factors. How did we get those values of F? So again, if I did 10.3 divided by 1, that's that mean squared. If I go back to the green, I can get that. And then if I go back into our for friends, thank you for your patience. All right, I'm getting this. And then we know that everything is divided by residuals. And I'm going to have to make this a darker color. So residuals, remember, is also called error, or it's our within variance. All right, so then to get this F, I would have done 48 divided by 15. That F right here, that's so big, is those two. And then this F that's so small is those two. So now let's take a look at effect size. Remember, there is a possibility that my effect size might mismatch with my findings. So when we look at effect size, we need to look at our R squared distribution for what's small, what's medium, and what's large. So I'm going to go ahead and have us switch over to this slide. So this is from your PowerPoint videos, and you can see eta squared or R squared. A 0.01 is small. Once we get a 0.06, we're at medium. Once we get to 0.14 or bigger, we're at large. So let's look at these. 0.034, we can note that as what? We're going to say that is small. So that's an interesting case where although we did not have we had non-significant findings, we still are seeing a small effect. So again, that could be one indication that perhaps we might have a type 2 error. There's something going on there between looking at our hypothesis testing finding and our effect size finding. For our state, 0.685, that is large. That means 68.5% of my variance in number of mutual friends is indicated or accounted for by state. That speaks volumes. 68% of the variance in mutual friends is explained by state. Then we have our interaction, and our interaction is part of that. No, nothing's going on there. And no, that's another nothing's going on there. And those two match. That is saying there's no effect in our R squared formula. So it's less than 0.01. And we also said, yeah, it's nothing going on. And I also said, yuck, less than 0.0 or less than 1 F ratio is terrible, 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 terrible. So a whole lot of variance going on there, though we still had met those assumptions for homogeneity of variance. Okay. So if we had needed to do post hocs, if we had a significant case for here, since our interaction is 4 conditions, we had 4 total conditions. So our N of cells equals those 4 conditions, or treatments, or levels, or groups. If that was significant, then I would run a post hoc. It is not significant, so I don't even need to look at this. So again, post hoc usually indicates when something's going on there. And typically with post hocs, the most common is the Tukey. So we had discussed post hocs in chapter 9. It is showing there's something going on there between being a family member and living out of state, having differences with mutual friends. But again, we had some issues with F, and so that's not something we would look at because our F was not significant. I should say our F for our interaction. So that means no post hoc. All right, so I did want to go ahead and show you, this shows you my next, portion of this output is going to show you your estimated marginal means. So your estimated marginal means, remember marginal means are those columns on the outside. So this is showing it, although it got cut off, this is for family. And you can see this was where the mean is for family. And this is where the mean is for friend. So friend was 2. And then family was 1. And then same thing with marginal means for state. This was people who are living in my state, Arizona, and this was you're not in Arizona. For those 2 categories for state. And again, this was a case where we found significant findings. Again, you can see how these confidence interval bars do not touch. There's lots of gaps between there. That's a good sign. Here you do see these bars touch. Again, when your error bars touch in a graph, that usually indicates you don't have significant findings. So again, this was a main effect showing those main effects. And then here, this is our interaction graph. So although you're seeing some touching going on, you are seeing, again, more of a parallel line fashion. And so this is showing, again, there's that no interaction. And again, each one of these dots is the means. This shows my 4 conditions. So I had 2 for family, and then I had 2 for state. So there you go. I hope that this helped clear things up with some of the output, and this will help guide you for your homework for this week. Hope you're having a good week, and thank you again for watching.